Hi students, in the previous chapters we've learned a lot about resistance, isn't it? In this chapter we will learn what happens to the resistance of the system when we combine 2, 3 or more than 3 resistances together. There are in fact two ways of combining resistances, series and parallel combinations. So we will understand what a series combination is and what a parallel combination is in this chapter. This chapter is called resistance of a system of resistors. What happens when more than one resistor is combined with another one? So let's proceed. Here we go. First of all, we need to understand that there are two ways in which we can combine resistances. These two ways of combining resistors are called series connections and parallel connections. Understood? The first thing we will study is a series connection. So what are series connections and parallel connections? Take a look at this circuit. As you can see, in this circuit there are three resistors connected side by side, isn't it? This combination is a series combination. In series combination, resistors are connected edge to edge. So you can see there's a battery, there's a key, there's an ammeter, there's a voltmeter, and three resistors are connected. And they are connected one after the other in the same loop. This kind of a connection is a series connection. Here, take a look at this kind of connection. This is a parallel combination of resistances. In this case, if you observe carefully, the resistors are connected only between 2 points. All the three resistors are connected between this point here and this point here, isn't it? Between the same 2 points. They are not connected edge to edge and they are not connected one after the other in the same loop. All of them form a different loop with the battery if you observe carefully, isn't it? This is one loop, this is another loop. So whenever many resistances are connected between two given points, we say that they have been connected in parallel. Whenever many resistances are connected one after the other in the same loop, they are said to be connected in series. Understood? Now a question might arise. How will we combine these three resistances? How can we find one single resistance that can replace all these three resistances in parallel? Similarly, in the previous case, can we find one single resistance that can replace three resistances in series? The resistance that can replace a combination of resistances in parallel or series is called the equivalent resistance of the system. So instead of these three resistances or four resistances, you can have just one single resistance of a particular value. That resistance will be called the equivalent resistance of the system. Understood? So we'll learn how to calculate the equivalent resistance in the case of series and parallel connections as we continue in this chapter. In fact, there are three things that we will find in case of both series and parallel connections. Consider this series connection shown here. In this case, what is the current through each resistor? This is the first thing we will find. So, what is the current through the first resistor, the second resistor, the third resistor? We'll find that out. The second thing we'll have to find out is what is the potential difference across each resistor when the resistors are connected in series. So if there's a battery of potential difference V, in that case what will be the potential difference here and here and here? That we have to find out. And just as I told you some time ago, we'll have to find out the equivalent resistance, that can replace all these three resistors in series. Understood? One resistor R that can replace R1, R2 and R3. Now scientists, after conducting experiments have found out that if there are three resistors R1, R2 and R3 in series, then they can be replaced by an equivalent resistance R such that R is R1 plus R2 plus R3. Understood? So in series, the equivalent resistance that can replace all the resistors in series is R equal to R1 plus R2 plus R3. If there were four resistors in series, the equivalent resistance would be R equal to R1 plus R2 plus R3 plus R4. So no matter how many resistors there are, you just add up the resistances to get the resistance of the equivalent resistor R. Understood? So we can have R such that R is R1 plus R2 plus R3. Let us actually conduct an experiment to find out some other features of a series circuit.